part and also the geological part, because the name of this tiny organism is different. Okay, at my right hand side is the benthic foraminifera, and on my left hand side is the benthic foran. So this shows the distribution of foraminifera. It can occupy on the sea surface layer, intermediate water, or deep water. For the benthic, of course, is only can be found in the benthic in the sediment. Okay, so here is the distribution of foraminifera based on the water depth from the shallow, intermediate, and also deep water. Normally, we use the surface or shallow drifter here, shallow foraminifera, to know the sea surface temperature. Okay, this also we use in the study. It is a coral skeleton for the inorganic marker. Okay, this is how data 018 represent the salinity and precipitation. I told you before that there are two different isotopes, data 016 and data 018. So, to represent the water salinity, normally we use the data 018. Because of what? When the evaporation occurs, data 018 is heavier than data 016 we left in the ocean. So it represents the salinity. So for the ice record here, the ratio of data 016 to data 018 to data 016, normally we can get the negative value here. Don't worry. Don't be so frustrated that you have the negative value when you analyze the ice score record, because of normally ice score record will show you when more data 016 average of data 016 depleted in data 018, you can get a minus value. Okay, and for the organic proxy here, we use the sediment, and alkane, teraxerol, alkanon, GDGT. Wow, it's a bit tough. You know, that's in the organic chemistry. We deal with a lot of chemical structure, chemical compound. So we try to find out which one is suitable for the climate proxy. Okay, you know this one? Phylogenetic tree, which is from bacteria, archaea, and also eukarya. So, like I told you before, that all of the living organisms, we produce the chemical compounds, our own chemical compounds. It's same with the marine organism or land organism. They also produce the special compound of their own signature. Like this one, you know, the coccolithosphere, Emiliana Huxley, and Geopyrocapsa oceanica, they produce the alkanons or long chain ketones. So this chemical, okay, welcome. This component, this indices, UK87 and TAC86, come from alkanon and also GTGT. So we know the difference between this one, the shade color, is represent the cool interval, and the white one is what? Warm interval. So it's like a cyclicity here, and that's in between the warm and cool and warm is a termination event. So that's why we know the number. I put the number at the upper is a event. Termination 1 2, 3, 4, and 5. So we see that during glacial or cool period, the temperature is dropped, and when in the interglacial period or warm cycle, temperature increase. So it makes sense, right? So that's why we use this kind of proxy to know the cyclicity of glacial and interglacial. Okay, okay. It's like a world changes or climate changes, even in modern or paleo, they will know about this term: eccentricity, obliquity, and precession. This is like how the Earth moves. Okay, but for the eccentricity, it take about 100 kilo-year cycle. So that means if we know we get today temperature, we wait until 100 kilo-years to know the cycle. It's a longer time cycle, and you can see that this differentiate, right? Differentiate here, circle shape and elongated. So what is circle? Why this happened? Yes, gravity. Gravity of what? Gravity, yes. Gravity of what? Okay, the gravity of planet. You know, in our solar system, they have many big. They have big planets like Venus, Mars. What's else? Mars. Yes. What's else? Uranus, Neptune. Yes. And these planets in the solar system will influence the cyclicity, the way how Earth move around the sun. Because you know that even moon also will influence our tidal cycle. Okay, so we can imagine how the influence of the gravity from these planets. So and then obliquity is take about 4,000 kilo-years cycle, and this is about Earth tilt angle, axial tilt. So can we imagine sekiranya lah kita katakan kita punya world ataupun Earth is like the stand at 90 degrees. What will happen? 90 degrees, and you are facing sun. So what happened? Okay, there will be no season, right? Yes, because in the location of northern hemisphere winter also same, northern hemisphere summer also same. So that means tropical region always receive high insolation, solar insolation, and the polar region will not receive high solar insolation. So that means in the tropical region is keep warming, and polar region cooling. So there will be so that means ice in the polar will extend, but in the tropical region it's like warming. So the maybe will not receive high rain like today. Yes, high heavy flood like several days ago, right? So it's maybe happy.
No.
Okay, and then maybe every house we should put aircon because due to the high temperature. So and then the precession. You can imagine the top spinning when it almost stop. How the condition of the top gasing bila berpusing, bila hampir nak berhenti macam mana dia punya keadaan kan. This is like precession. Okay, any idea? Yes, changes of the temperature because of what? Okay, we go. What the issue today is about the energy consumption. When we use a lot of energy, what we produce? CO2. Yes, correct. CO2 is what we concerned about. The increasing of CO2. We know that from the industrial era, CO2 is keep increasing, right? These are the data from Mauna Loa in Hawaii. It shows that our atmospheric CO2 is keep increasing. And is it the modern phenomena? Yes. Only modern? No. Okay. Actually, this is like a cycle, that the increasing of CO2 also occurs in the paleo world. So, you can see here the CO2 concentrations and also here the methane concentration, which is greenhouse gases. And this one, so when the warm period, the CO2 increase and drop during the cool period. And just, you can see here the deuterium is the temperature signature, temperature proxy. You can see when during the warm period, CO2 increase and the temperature also increase. And this one, methane, CH4 also increase. And salinity also. This one salinity is decrease. This one, because you know that here salinity more negative is show that more fresher water. If a smaller number here is fresher salinity, and big number is show that very high salinity. So, and then southward drift of Tropic of Cancer. We have Tropic of Cancer, Equator, Tropic of Capricorn, kan? Gemini ada? Tipu lah, Gemini lah ada. Okay. Okay. Where is the Tropic of Cancer? Here, the Tropic of Cancer is the 23.5 latitude. And then, what is the special about this Chiayi Taiwan? Chiayi Taiwan. Okay, actually, where the monument built exactly on the Tropic of Cancer during that time in 1908, the first time. And then after years by years, they are measured that's place. So that's mean they notice that the Tropic of Cancer move southwards about 14.4 meter per year. So every year is moved about 14.4 meter per year, and it will take about 90 kilometer to go, and to reach the maximum of tilt angle. It's about here 24.5. So now it's 23.5, and then this like when it reached the maximum, and it will go back to the minimum tilt at 22 degree. So I just speculate that this one also affect our climate change, Because of what? Because can you see here at the part of North Pole, what happened when the degree become larger, especially during Northern Hemisphere winter. No, I mean winter, during winter. So what will happen? Okay, boleh nampak kat atas tu, tidak banyak kawasan yang akan terkena cahaya matahari. So it's become colder in the top of North Pole. So this happened, early severe cool temperature in US because of what? You know that ice cover in the Arctic Ocean is shrinking, semakin mengecil kan? So when it's shrinking, it's like you know that's around the Arctic Ocean there is Arctic continent. I mean the North Pole. They have we call it polar fronts or jet stream. What the function of this one, jet stream?
The meeting of cold.
Untuk menghalang daripada Arctic wave. Kita panggil Arctic wave. It's very cool temperature enter to the northern, I mean to the southern part or to the temperate area. So when is this happened, climate change, global warming will disturb this cycle and make it to the vortex. I mean the jet stream becomes slow, and then so the jet stream will enter to the US. So this happened when we call it Arctic wave enter US. You can see here the white color there is the cover by snow. In US, you know that last week 50 states in America covered by snow, not the normal snow, but the severe snow drop during that time, and the temperature dropped until maybe -7 degrees Celsius. So you can see here, car covered with the ice, it's not snow, and then this one, bicycle covered with the snow or ice, and early sign of northeast monsoon.
UMT.
In where? This year. UMT also facing the have big flood. UUM 23rd November. So normally back to 10 years ago, we see that if northeast monsoon, it only affects the east coast region, peninsula Malaysia, like Terengganu, Pahang, or Kelantan. But now you can see in the whole peninsula Malaysia is affected by rain.
Yeah, UUM and Changrun is on the.
So is this
West Coast.
phenomena is a coincidence? I think it's not a regional event, but it's more to the global factor. So you can see here the low pressure and high pressure zone between the polar cell, ferrocell, and Hartley cell. So here, the intertropical convergence zone is the zone is very wet. You know that's very wet. China also facing the same penetration of polar vortex, and UK also facing the same situation. So this is what happened. 19 November in US and Canada, where the polar vortex enter this country, and the cool temperature occur in these two countries. And then next, UK, they also expect that UK also facing the same situation, of the polar vortex intrusion. And the next is China. When is enter China, how about temperature in Malaysia? Climates in Malaysia. Okay, you still remember with this article? When the temperature in the the cry is dropped until 7 degrees Celsius. So maybe next January or earlier, we will facing the same temperature or same weather. The temperature will drop.
So it's become an
In the Terengganu also during that time, maybe 20 degrees Celsius or 22 degrees Celsius, right? Yes, if I'm not mistaken.
Can I buy a hoodie now? We go down.
Okay. And this one is the winter. How about the summer?
Intensify.
Okay, we talk about the angle more to the southward. And then this one is winter, more severe temperature, cold temperature. And then how about the summer? Increase of solar insolation in the northern hemisphere, polar ice melting, of course. Now we're talking about the Arctic ice melting. Yes, if we compare maybe back to 20 years ago or 30 years ago, the ice in the Arctic is like a shrinking. Okay, sea level rise is happened in the Maldives, and they expect that several area, lowland area in Singapore will cover with the sea water due to the sea level rise. Okay, in our here in Terengganu also, they discovered that from coral skeleton remained in the Bukit Bucu, maybe 3 kilometers or 2 kilometers from here, they can find the coral skeleton there. So, what you can imagine in UMC, if sea level rise until that level, so is still UMT be here, or we should move to the higher place?
Maybe under the sea.
Or,
Fully
or we should prepare more scuba equipment here. Okay. Okay. And the fourth is north migration of forests.
Migration.
I think.
Forest?
Do you know this one?
No.
The fourth one,
No.
north migration of forests.
No.
No. Okay. What will happen? The north migration of forests. Okay, this is June solstice. Okay. So the white color is show the ice cover during the Pleistocene, 18,000 years ago, and then this one show in the modern days how the ice cover is this. You can see very big ice cover in the polar region, and this one in the modern day only a small part covered by ice. So, and then you can see here the boreal forest and also boreal forest and also temperate forest keep coming to the polar region. This one. We compare here, the pink color is Arctic tundra, and green one is a boreal forest, yellow is a temperate forest, and woodland and grassland. So based on the current study, they know that this migration occur, and the forest is keep moving to the northern, to the polar region. Because of what? Because of no ice cover, and boreal forest move to the north or polar area. And it's also same with the temperate forest. It's keep coming to the boreal forest area. And this is like two different phenomena. First is during cool, and second is during summer or warm. Okay, how about our Earth in the future? Ice-free world or snowball like that in Ice Age film? So we don't know yet here, but we know that our ice is keep shrinking and our temperature is increasing because of global warming due to the the increasing of CO2. You know what the CO2 function? How the CO2 affect our temperature, global temperature? It's like a huge blanket. You know that's CO2 or greenhouse gases. Huge blanket to our Earth. It's cover our Earth. Sun ray or insolation can enter our Earth, but it cannot be reflect back to the outer space. So the temperature inside our world is keep increasing. That's why we call it global warming. So what keep changing? Yes, based on the proxy that we use to know the our climates, paleoclimates. So semacam dengan sejarah kita juga kot. Kan, sejarah kita kerap berubah kan. Bila ada penemuan baru, okey macam ni tadi. Muncul tak ada Sultan Melaka kan. New Sultan Melaka. Okay, that's all. Thank you from me.
Jumpa doktor untuk kontomik. Tapi tak tahu nak lagu apa.
Happiness